Yes, hi, good afternoon. And the title of my presentation is Can You Outlier? The presentation is brought to you by Mr. Oluwatosin Ogunshile, and thank you so much. Right, so why do we need to worry about outliers? Well, outliers helps you in many ways. One of them is to eliminate bad data and in reaching a better conclusion, and it also affects outcomes. So, and one of the food for thought when you think about outliers is would you keep vegetables with oranges? Would you keep your onions with potatoes? It's very important when you think about that because when things are out of sync, then you know what the consequences could be. So, if you cannot, if you see vegetables, you want to put them together away from the oranges. And that's an example of what we mean by when we talk about outliers. Standard. The standard is a common core standard, and the Kentucky standard is listed. Interpret differences in shape, centers, and spread for possible effect of extreme outliers. So what is an outlier? Extreme ends of data that do not fall within acceptable range. And again, one thing to also keep in mind when we talk about outliers is the analyst or the author decides what is abnormal and what is normal when it comes to results. So it's very important for you to always keep in mind that every result has its implicit bias because the author does decide when what to keep and what to get rid of. So how do we find outliers? One of the ways you can find outliers is by the use of standard deviation. So in the normal standard deviation, 68% of the data should fall between the first standard deviation and about 99.7% should fall within the third standard deviation. Any digit or any value that's outside of the third standard deviation is considered to be an outlier. You can also use a box plot. You can find your interquartile range, after which you can then use that to find what we call the lower whisker and the upper whisker. So any data that is outside of the lower and the upper whisker, which can be found by multiplying the interquartile range by 1.5 and subtracting from Q1 or by adding to Q3. Any data that's outside of those is again considered an outlier. There are also other outliers that deals with technical terms, data processing or data. So one of them is the DB scan clustering. So any value that does not fall within the core point or the border point, they are called nose points and they are considered outliers. Same thing, we have another programming an algorithm here called isolation forest that's also designed to be able to again discuss and assign values to numbers and then use that to determine what values are considered to be outliers. Then you also have a robust random cut forest, which is an Amazon algorithm that's again designed to detect anomalies. So again, any values that's considered to be anomaly is an outlier, and is you know so that's what this algorithm does. So you can see lower score indicates that the data point is normal, and if it gives it a high value, then it means it's an anomaly, and then that could be removed. Now, why should we care again about outliers? So this is an example that I kind of came up with, and so in a class, I would definitely introduce something like this to students and have them discuss. It's a nice, good class discussion exercise, and one of the conversation would be, do cigarette smoking lead to early death in teenagers? Of course, you're gonna have a lot of students will say yes, no, and then they can have a brief discussion about that. But then if we agree that whether it leads to it or not, the focus is not whether it actually leads to that because we might not be able to draw the conclusion. It's to actually show the student what outlier does and how that affects the data. So the first is the data that's been released by company A, which is a cigarette company. And so in this data, the student will be provided this worksheet to be able to look at, and then they will see what the graph is. Hopefully, the student taking this class, probability class, they've already had some experience with slope, and so they know the difference between very steep slope and the one that's not so steep. So they should be able to transfer the knowledge into that. But let's say they've forgotten, there will be an opportunity for you to talk about rise over run. So you can tell them that what do they see about the rise over run. So students should be able to say, okay, from 1 to 8, it rose by 10, and it only ran by 7, and that is what gave us a slope of about 1.2414. And again, that is the slope of this data released by the company. So which again, the explanation of this data is to show that for every one increase in the cigarette value in the cigarette daily that's consumed, you have about 1.24 death annually. And again, this is a rough data that's just being provided to the student by myself. Now, the next thing you want to do is provide um, this and say, okay, if if you remove some of the data that seems to be off track from the explanation, what is the difference? So obviously, you expect the student to be able to tell that the slope has increased significantly, and also the R-square value, which shows the data point closer to the trend line. So this is a better data point, definitely, because the R-square is closer to 1, and it also shows that there's a 1.86 slope compared to what we had before, which was 1.24. Now, the significance of this is that instead of one increase in cigarette daily leading to 1.24 death, now we're talking about one increase in cigarette daily is leading to 1.89 death. Now, you might not think about that as very significant, but if we're talking about millions of people in this case, that's a really huge value and a huge difference that we're talking about. And I think that's what the student need to be aware of, that just deciding what data to use and what data to take off can actually affect how a graph would look like, and also the result that is going to be shown up from the graph. And so what is the conclusion of this is to show that there's a major improvement in the value of the R square when we factor in the outliers. In this case, we just use our own insight to say, okay, some of these data were just off and we should just take them off. But if we were going to do the types of the ways of doing outliers, we would use the normal distribution curve, or we use the box plot, and then we use that to figure out which of the values were kind of off, and that's what we use to kind of determine what we're going to get rid of. And in that case, then that will also guide us in what data we're going to use. So this is again to show the differences. So when companies release data to us, and when we get information, it's very important for us to look at those things and look for anomalies and look for outliers and look for some of those things, because it can make a major difference. Like in this case, there's a 52.4% increase from the first data in the number of people that can die based on deciding to remove the outliers or deciding to keep the outliers. So the next question, of course, is to throw to the question is, what would make the company release the false data as opposed to removing the outliers? Of course, they want to show that less people are dying from cigarette smoking because they want more people to continue to smoke cigarette. So and that's to also let the student understand that these are some of the bias that we talked about that you could see in any single information that you get out there. So when a company releases data, people should always look at it from the element of bias and use that to be able to figure out, okay, which one is the right data, which one is there any anomaly in this data and whatnot. And the same thing applies for us as student, as educator. Whenever we want to churn out data, it's very important for us to be mindful about how people will be able to critique our data and what that data is meant to show. So and a really segment way to end this class conversation will be, again, is it illegal to use bad data? It's not illegal. Companies do it all the time. Is when you know that there's a right data and then you purposely try to mislead the public by releasing the wrong data. That might be considered illegal. But sometimes, whether you decide to use an outlier or you decide not to use an outlier, that's not illegal in its way. But a company should always try to do good, and so you should always try towards trying to release data that truly shows that you've done what is needed in order to make the data appear very legit. And so that's what it is. And so this is an example where secondhand smoking has been considered to be safe for many years. It took decades for people to understand that data were being manipulated, and in fact, secondhand smoking and smoking itself is actually very dangerous to people, and especially to teenagers because of their growing brain. So that's where, so thank you so much for taking the time to listen to my recording on Outlier. I really appreciate that, and have a good rest of your day. Bye.